Coders, welcome to my video. So in this video, I will be touching on the socket API itself. Okay. So as a system developer, we often use sockets and we have a list of APIs while using a socket server client. For example, we have socket bind, listen, accept, close, send, and receive system calls, but we don't give much time to analyze the single APIs like socket. Okay, we only know these are the inputs and this is the output. So in this video, we will be digging deep from the user space system call to the kernel part. Okay, so for example, when we hit this API, what actually happens under the hood? From user space to the kernel space itself. Okay, and after this system call is being executed, we are getting a file descriptor. So how this file descriptor are returned by the kernel space. Okay, as you already know, socket is a API that we use in network communication between the two PCs in the same network or in a different network itself. We have IP and a port connected with this socket. Okay, so we will trace this socket system call in this video from user space to the kernel space. Okay, so let's quickly start with this socket API. So this is a system call, and here we have the first parameter, that is the domain. Okay, and next we have the type of the socket which I need to create. Okay, and the third parameter is the protocol. So this is mostly zero because these two fields will decide the protocol, and it is automatically be selected by this socket system call. And once this is done, we get a file descriptor. Okay, so we have list of option here. IPv4 stack, we have AF underscore INET, uh, AF underscore INET 6 for IPv6 stack, and we have local sockets as well. So for that, we use this AF underscore Unix as a local IPC mechanism. And for the type, we have socket stream and socket diagram. These are some of the important ones. And this third parameter is automatically be taken depending on these two parameters. For example, I am using TCP socket IPv4, so it will take AF underscore INET and socket stream. So these two parameters will decide that we are going for the IPv4 stack, and this is the protocol which we are using, so it will automatically decide. So let's quickly go to the man page of the socket API to take more on this. So if we have man socket, so if you open this man page, so we get socket creates an endpoint for communication. Okay, that we already know. These are the two files that is including while we are using the socket API. We have sys socket.h and sys types.h. And as a socket API, we have domain, type, and protocol. Okay, this already discussed. So socket created endpoint for communication and return a file descriptor that refer to a endpoint. The file descriptor returned by a successful call will be lowest number file descriptor not currently open for the process. Okay, so for domain, if you say it is specific for communication, so we have AF underscore INET. We already see this is IPv4 internet protocol. Okay, we have others as well. If you go down, we have this netlink sockets also to communicate with the kernel. So kernel user space interface device, we can use this type of domain socket, and we have lot of others. And AF underscore Bluetooth, this is for Bluetooth communication. So this automatically be associated with one of the protocol that we are using. Okay, so second is the type is socket stream. So we have stream of bytes, reliable communication, two-way communication. TCP is a three-way handshake, that all is done by this socket stream. And for UDP connections, we have socket diagram, we have sequential packets, we have raw packets as well. This is used for IP, that V4 ping or IPv6 ping, we use ROC sockets provide raw network protocol access. Okay, so on success, a file descriptor for the new socket is returned. On error, -1 is returned. And in case of error, an arno variable is set. So if you don't know about the arno variable, you can see my last video. Okay, so and these are the related arno errors that we have. Okay, so this gives you a complete overview. What are the inputs and what are the output for this socket API? Okay, now let's close this and we'll get back to our program and we'll check the flow from the user to the kernel space. Okay, so for a generic view, we can see this socket is a system call that is there in sys socket.h that we already seen. So it is attached to a glibc wrapper. So libc we are using as a library function that is included in this library. So we use that function and it ultimately called the sys socket. Okay, and we have protocol family lookup. For example, sock stream, we have TCP and UDP, and these all things are decided um, in kernel space, and that particular stack is being loaded for this socket to work. Then we have socket allocation. So this is done as a part of a kernel, as a kernel object. So when we hit the socket API, it only create uh, some space and environment variable for that FD. So it is not associated with bind right now. Okay. So it won't be seen in when you use netstat, you won't see this socket because it is not been attached to any of the IP or a port. Okay. So attach TCP and UDP operations. So all the kernel stack operations are allocated with this file descriptor. And here we have the file descriptor allocation, and this is returned to the user. Okay, whether any number 1, 2, 3, something like that. So one, not 1, 2, 3, because 0, 1, 2 is reserved, and 3 we can get. I think from 3 onwards we can get as a part of this socket file descriptor. I think we are clear till now. So let's jump to a code simply. So if I go to simple socket API I'm using here and returning an FD. If FD is less than 0, we get a P error of socket failed, return 1, and the program exit. If it passed, it will print the FD and the PID. So this is very simple program. I'm not using lot of APIs. I'm stressing more on the single API. And here we have socket.h that gives you this API, that declaration. Okay, so if I close it and I use GCC socket API and -o sock API, okay, there is simple warning. Okay, so this we can ignore, and if I run sock API, so you will see the socket is created, file descriptor is 3, and the PID that is created is 2768. Okay, so if I go to /proc 2768, so it's not there. Okay, so it means this program got exited and we don't have the proc entry. So to make it more clear, what I will do, I'll open the socket API, and what I do here, I'll create a sleep simple 100 seconds so that it won't close before I see. So then I'll use GCC again. Okay, and then I use socket API and I run in background. So once I run it, you get a PID of 2776. Okay. So I'll go into the proc entry 2776. Okay, now it's there. So if I go there and cat fd, you will see you will get an entry over here. Okay, so 012 is input outputs, but here we have fd3. Okay, if you create any other socket in this program, it will give for 4. So similar to this. So this fd is created in the kernel space. Okay, and if I say netstat -nalp and I grep for sock, uh, what is the name of the API? Sock API. So sock API, we won't see anything. So it's not there. Okay. So this will be reflected when we use a bind system call. So now let's go again to the code we have. And now I will tell you what all kernel files are being involved in this socket API. So when you hit socket, this is the flow. So this I find out by checking the kernel trace. So I'll show at the end how I use this. Okay, so here we have the socket API. So this is a user space call and it will go to kernel space socket.c. So here we have a system call 3 socket. So this is being hit when any program call this socket API. Then in the socket.c itself, there is one file sys socket. This has been called sock create. So we get two structure here, struct sock and struct socket. So these two structure, I will tell you using the later videos, but here we only have struct sock and struct socket. Okay. So now your socket is allocated here. So it is also in the same file itself. Okay. So depending on whether your type of the socket is IPv4 or IPv6, it will check these files in the kernel space. So inet create will be there and it will be called depending on IPv4 and TCP UDP. It will select is appropriate function handlers, and at the last, if you see here, we have file system file.c and you get unused fd flags here. Okay, and after you get the unused fd flags, there is a call sock map fd that will return the fd to the user space. Okay, so what all are the steps? If we rewind it, you have a system call, it got hit here. Okay, then you have socket create, you have sock allot, then we have inet create for TCP UDP, sock stream and sock that UDP thing, and TCP and UDP they will select here, then they will get the number of unused FD and you get a file descriptor and it's being returned. Simple as that. Okay, so if I check the kernel code itself, so if I am using bootlane here to browse our code, so you can go to this link to check the kernel APIs that is being used. So this is the root of your kernel. So these are all the files that is there in the kernel. So we are most interested in getting the file socket.c from net. So if you go here and you will check the socket.c file, and from here what you need to see is this 6 API. So I copy just here and I'll go here and if I search here, okay, so this is that function that is being called when you hit socket API, you get family, type, and protocol all there, and then it will switch to sys socket. So it's defined here. So if you completely go here, you will get the definition of this here as well. Okay, so what it do, it will call sys socket create. So this will create your socket, mask it whether non-blocking or blocking, it will choose and it will map your FD. If you go again to this sock map FD, you will get unused FD flags here, and then you will allocate the file, respective file related to that socket. So if you want to check other files, you will go here and what is the other file we have? We have IPv4, AF, and INET. So you can go there and if you check here, you have got the AF underscore INET as per the flag you have. Okay, so here you have list of APIs and we have INET create here. Okay, so I'm not going deep into this thing, but at the end you would get a networking socket structure being defined as SK allocate here. Okay, and what else we find out here is we'll get a unused FD flag and then we map this FD mostly. So this map FD we have already seen and it will return your FD to the user space. So this is all about to check the flow directly into the kernel. So next part, what I'm going to show you in a live kernel, we can trace this flow of this socket API using these three things. So first, we need to enable the ftrace in our kernel. So I will just copy it. So first, I'll copy this thing. So all the function graphs I want from system call, that is socket what is we using. So next is we don't need everything. So we have x64 system and underscore sys socket is an API. So we need the graph when this function got hit. Okay. So we have to insert this as well. And the third, we have to enable the trace. So once I enable the trace, then what I need to do, I need to compile my function, what I already have. And if I run it, okay, it's and now what I need is I open it again and I will check this trace of this function graphs. So if I use here, you will get a lot of things here. Okay. So what this actually is, this got hit. After that, underscore underscore socket got hit. Socket create, secure socket create, and these all things. Then we have socket alloc. Okay, and these all things is not much interested in, and you have fd install. Okay, so these all things you can trace a single system call depending on your uses program. Okay, so this is all about this video. You can go through this all the data and you can try to trace this socket API. You will get more insight of these sockets. So a socket API is just not calling that API in a program, but it has lots things to do with the kernel. Without the kernel intervention, nothing can be done for this socket API. So this is all about this video. Let's see in the next video. Thanks.